Hello, I'm Rob here. I'm on the first page of the notes for multiplying and dividing integers. I have a little doodle of myself over here saying, looks like a good page for vocab. So when you get your next vocabulary assignment, make sure you come back to these notes for lots of the answers. Do not go to Google first. Matter of fact, I recommend mathisfun.com in place of Google. So let's read through this. Multiplication. When you multiply numbers, those numbers you multiply together are called the factors. The answer to the multiplication problem is called the product. And the reason why I did adding and subtracting chapter before I did multiplying and dividing is because you need to know how to add before you know how to multiply. Because multiplication is repeated addition. If I have 4 times 3, I can write that as 3 groups of 4. Could have also written it as 4 groups of 3. Either way, the answer would have come out 12. And if we're going to go to the next level, we would do exponents, which is repeated multiplication. The number down here is called the base, and this tiny number up here is called the exponent or power. I discussed this when we did place value. This is written with an exponent, hence exponential form. When you did this in elementary school, you expanded it out. That 2 means I multiply the base times itself 2 times. That's expanded form. And then the final answer is called standard form. Okay? Division is the separating of something into parts or groups. It is the number of times the divisor goes into the dividend. Then this is in the numerator. The divisor is in the denominator, and when we did long division, the divisor knocks on the door. The dividend is inside the box. The answer to a division problem is the quotient. I can't even tell you how many vocab words we just did already. So, just like adding and subtracting are related because subtracting is adding an opposite, multiplication and division are related. They're opposites of each other. I can change a division problem into a multiplication problem, just like I can change a subtraction problem into an addition problem. 12 divided by 4 is what? Is the same thing as saying 4 times the what is 12. And we all know the answer there is 3. Undefined. This is what makes us up a level to middle school. We can do things like undefined. There's no answer. You can never divide by 0. If you did 2 divided by 0 on your calculator, it will tell you error. It's undefined. Do not forget order of operations, PEMDAS, parentheses first, then exponents, multiplication or division, depending on which one came first, addition or subtraction, depending on which one you saw first. 0 property of multiplication. Anything times 0 is 0. Multiplicative identity property, anything times 1 gives you back itself. Identity gives you back itself. Commutative property is changing the order, but the product stays the same. And just to digress for a second here, why can't we divide by 0? Well, it goes back to what we were saying up here. Something divided by 0 gives me an answer, right? If I rewrote it like I rewrote it up there, 0 times what would give you some number? We could use 5, okay? Since this x might be hard to understand, you use a number instead. 5 divided by 0, we are going to find out is undefined. But to check ourselves, we rewrite this as a multiplication problem. And ask yourself, what can you multiply by 0 and it gives you 5? Absolutely nothing. That's why it's undefined. You can't multiply by 0 and get anything but 0. Okay? So that's a great page of notes. Now we're going to go into multiplying and dividing with negatives, which we haven't done before. Our calculator can certainly handle this, no problem. But, as like all my other pages of notes, I want to get into the why. So that's what we're going to do. We're going to do 4 times negative 3. Without knowing the rules or the shortcuts, let's start with doing it with a repeated addition. That's 4 groups of a negative 3. 1, 2, 3, 4. I always like to make my negatives stick out so they don't blend in. So if we go back to chip diagrams, 4 sets of -3. There's 1, 2, 3, 4. What do you see? You see 12 negatives. Another way to look at this, instead of reading the 4 first, I can do like commutative property. I can remove 3 sets of 4 positive chips. Okay? So right now I have nothing on my paper. There's nothing to remove. So I'm going to write a 0 because that's nothing. And I am going to write a whole bunch of zeros because I need to do a whole bunch of removing. I need to remove 3 sets or groups of 4 positives. I can see 4 positives here, but that's only 1 set, and I need 3 sets. So here's my second column and my third column. What number do I have on the paper right now? Now this is a little difficult, I understand. I have zeros, I have a bunch of zeros. But now I'm going to remove, and if you remember from our chip notes with subtraction, removing is a light shading. I'm going to lightly shade 1 set of 4 positives, 2 sets of 4 positives, and the third set of 4 positives. And I can see what's left over is still 12 negatives. So basically, in this problem, and I did it forwards and backwards, I did 4 times -3, and I did -3 times 4, because they both come out the same answer because multiplication is commutative. I basically multiplied a positive with a negative and I got a negative answer. All right, so I went over an important word here. Removing is a negative. So if I wanted to write this out in words, because we're going to have to do word problems. Right now I'm not dealing with real life stuff, but we will. We are going to, we have a takeaway 2 here, so we're going to remove 2 sets of 4 negatives. This would be easier way for you to think of it. So I'm multiplying 2 negatives, which we've really never done before. So some of you might know what happens when you multiply 2 negatives, but I'll bet you didn't know why. No one ever taught me why. So if I'm going to remove 2 sets of 4 negatives, I can't put 4 negatives on here because I literally have nothing to start with. So we got to make it a 0. But that's 1 set of 4. It says I'm supposed to remove 2. So I got 2 sets, 2 columns of 0 pairs with 4 0 pairs each. And we're going to remove 2 sets of 4 negatives. There's 1 set of 4 negatives. There's the second. And the answer is a positive 8. And that is why when you have 2 negatives multiplied, it makes a positive. Now please be careful. This is multiplication, not adding or subtracting. When I add a negative with a negative, I'm still getting a negative. Most students often can, try to summarize these signs and then they forget, well, we're talking about multiplying right now. If I'm talking about addition, it's not going to come out positive if I add a bunch of negatives. So, you know how to multiply positive times a positive. We always got positive. You used to do problems like that all the time. And a negative times a negative came out positive, and a positive and a negative came out negative. We got 2 kinds of signs here. We got positive, positive, negative, negative, which I don't like to write because writing same signs is much easier. And then I got a positive and a negative, or a negative and a positive, which come out different. The signs are either 2 of the same or 1 of each, different. When the signs are the same, the answer will come out positive. When the signs are different, they will come out negative. And that's all you need to know. Truth be told, unless we're doing something with letters, then you don't really need to remember this. And we will do things with letters. But if we have a problem with all numbers in it, you just use a calculator. calculator do the work for you. Okay. Please remember, negative can go in front, on top, or in the bottom. But this way is the best way. The calculator doesn't like the denominator, and I don't like it in front because sometimes it might get lost with the division or the fraction bar. Okay, so let's reiterate something here. This was on the Sum Chapter 1 vocab answers page. I went over words for negative. If we're talking about money, you could use a word like withdraw or withdrew or withdrawal. We definitely use the word remove a bit. You'll hear take away. Again, with money, things like debt. If you want more words like that, they're on that Chapter 1 vocab answers page. Now, don't forget, if I'm removing a negative, if I remove a negative, you turn out positive. If you have somebody in the room with a very negative attitude and you remove them from the room, you will feel more positive. If you owe me money, you better hope you don't owe me money. But if you owe me money and I forgive you, I'm going to forgive you, I'm going to take away your debt. If I take away your debt, you should be happy. It's a positive thing. You don't owe me money, but the next time you owe me money, you better pay me. All right, so let's talk about some examples. This is all typed up nice and neat so you could reread it when you need help writing a real life problem or understanding one. So check it. I got negative 3 times 5. I sacked the quarterback for 3 yards. All 5 times I went on the field. Y'all, I'm like Pro Bowl quality football player. Sacking is pushing someone back. That's why it's negative. I did it 3 times. I pushed them back 3 times for 5 yards each. Oh, here's a harder one. 2 negatives. A negative 6. Oh, by the way, why don't we write the answer to this? Okay, so if I sack the quarterback 3 times for 5 yards each, I push them back 15 yards because the signs are different, so the answer is negative. You can check it in the calculator if you don't believe me. I do make mistakes on occasion. So for the 2 negatives, it's kind of hard to do that one, so we revert to the very, very boring integer card game. And remember, the integer card game is about adding. But multiplication is repeated addition. So I can remove 6 of the negative 3 card. So that would be like negative 3 plus 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 negative 3. Did I do 6? And that would increase my score by 18 points because when the signs are the same, the answer is positive. When I remove negativity, I get positivity. Okay? Here's one more last example with 1 negative in it. 4 times negative 7. If I borrow, that would be the negative right here. $7 for my mom. I borrowed $7 from my mom for lunch 4 days of the week. So, borrowing is negative. That would mean I owe her $28 because if the signs are different, the answer is negative. Okay? Now we're going to try problems on the next page, and anything that's left over, you're going to try on your own. And not going to lie, some of those problems are going to be challenging. If you're using Cami, it'll be great because you can erase. If you're using paper, I hope you're using pencil because you will probably need to erase. Okay, there's some more notes up here for you to read. I'm going to jump into question 1. Natalie's playing the integer card game. It must be raining and the power is out. She must be very, very bored. Find the sum of the numbers. And she only shows you these 4 cards below. She tells you the rest of the cards have the same values on them and match one of these cards. Okay, so this is 1. We got parts A and B, so they all refer to these cards. So if all the matching cards will increase her score by 18, please get in the habit of underlining Important information. What could her cards be? So which one of the numbers added to itself multiple times will make the 18? I need to make a positive 18. So what topic are we doing? We're doing multiplication. What can you multiply? Which one of these numbers is a factor of 18? The 2? 2 times what will make 18? 2 times 9. Which one's the card? 2 is the card. So these are how many cards there are. 9 of the 2s. 9 of the 2s. There's another one. You could have done what? There's a 3 card. That's a factor of 18. You could have done 6 of the 3s. And that would increase your score by 18. Right? 9 of the 2s. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Multiplication is repeated addition. That's why I can use the integer card game, because integer card game is addition. Okay, if all the matching cards decrease her score by 12, that would be a negative 12. What would be the card? So think to yourself, which one of these is a factor of 12? Okay, so I only got one in here that's negative. So for the decrease, I would use the negative 6 card, and I would need how many of them? 2. 2 groups of negative 6 will give you the negative 12. And that's the only choice for that one. Okay? All right, let's look at the one on the bottom. A hand of 6 integer cards has one matching set of 2 or more cards. One matching set of 2 or more cards. If the matching set of cards is removed, super important word. Removed means it's going to be taken away. It's negative. From the hand, the score will increase by 6. So for an answer, I'm going to get a positive 6. What are the possible matching cards? Explain. Okay, so I'll put the card here, and I'm going to put how many groups of something here. I'm removing something. So I'm going to put that in the group section. I'm removing, taking away how many groups of what kind of card. Now let's go over the rules again. The signs have to be what to come out positive? Signs have to be the signs have to be the same to have a positive product. If I want positivity, I got to remove negativity. So now, tell me, what do you multiply to get 6? What are the factors of 6? I can remove 2 groups of the negative 3 card, or I could remove 3 groups of the negative 2 card. So I'll write that down. Remove 2 groups of negative 3, or remove 3 groups of the negative 2. Okay, so on the back side here we have questions for you to do for homework. Cards that increase your score by 8 points means what do you multiply to get positive 8? Cards that decrease your score by 9 means what do you multiply to get negative 9? One of these will be the cards, and the other ones will be the groups. This question is pretty long. This question is pretty challenging, but I have faith that you can do it. Okay, do it to it, and then submit it when you're done. Make sure you fill this all out